Is humanity unique and alone in the vast cosmos? This conundrum, summarized by the well-known Drake equation, has been one of the most intractable and uncertain in science for decades. A new study demonstrates that the recent discovery of exoplanets, and a broader approach to the question, make it possible to ascribe a new empirically valid probability to the existence of other technologically advanced civilizations. Welcome back to my channel. Drake equation updated. Are we really alone in the universe? Frank Drake, an astrophysicist, created an equation in 1961 to estimate the number of advanced civilizations likely to exist in the Milky Way galaxy. The Drake equation has proved to be a robust research framework, but since 1961 space technology has increased scientists' understanding of numerous variables. However, it is unfeasible to make more than educated guesses regarding variables such as L, the likely longevity of other advanced civilizations. And it demonstrates that unless the likelihood of advanced life evolving on a habitable planet are astoundingly low, humankind is not the first technological or advanced civilization in the universe. The question of whether advanced civilizations exist elsewhere in the universe has always been troubled with uncertainties in the Drake equation. We've known for a long time approximately how many stars exist in the universe. We didn't know how many of those stars had planets that could potentially harbor life, how often life might evolve and lead to intelligent beings, and how long any civilizations might last before becoming extinct. Of course, we have no idea how likely it is that an intelligent technological species will evolve on a given habitable planet. We can tell precisely how low that probability would have to be for us to be the only civilization the universe has produced. We call that the pessimism line. If the actual probability is greater than the pessimism line, then a technological species and civilization has likely happened before. We know that intelligent life is possible at least 1 in 10 to the power of 22. There are 10 to the power of 11 stars in a galaxy, and there are 10 to the power of 11 galaxies in the observable universe. Looking at this order of magnitude, 10 to the power of 22, the odds are pretty grim. 1 in 10 billion trillion is a minuscule probability, which suggests that other intelligent, technology-producing species likely evolved before we did. Before this result could be termed pessimistic, the odds of a civilization evolving on a habitable planet were 1 in a trillion. But even this estimate implies that what has occurred on Earth with humanity has in fact occurred approximately 10 billion times before, in cosmic history. The figures for smaller volumes are less extreme. For instance, it is probable that another technological species has evolved on a habitable planet in our own Milky Way galaxy, if the odds against it evolving on any other habitable planet should be greater than 1 in 10 to the power of 11. Pessimists may find solace in the Drake equation, which calculates the odds that other civilizations exist today, if these numbers appear to be optimistic regarding the existence of alien civilizations. We now know that roughly 1/5 of stars have planets in habitable zones, where temperatures could support life as we know it, thanks to NASA's Kepler satellite and other searches. It remains uncertain how long civilizations may endure before go extinct for whatever reason. The fact that humans have had primitive technology for roughly 10,000 years does not tell us much about whether or not other societies would last as long or longer. Instead of inquiring how many civilizations may exist now, it would be more appropriate to inquire whether we are the only technological species to have ever existed. This eliminates the uncertainty surrounding the civilization lifetime issue, and enables us to investigate what we refer to as the cosmic archaeological question: how often in the history of the universe has advanced life evolved? The new research provides a new equation to answer a slightly different question: how many advanced civilizations are likely to have arisen throughout the history of the observable universe? The revised equation is based on Drake's equation, but L is no longer required. The argument depends on the recent discovery of how many planets exist, and how many of them are in what scientists refer to as the habitable zone, or planets with liquid water and the potential for life. This permits the definition of the NAS number. This is the product of n, the total number of stars, Fp, the fraction of stars that form planets, and Np, the average number of planets in the habitable zones of their stars. The archaeological form of the Drake equation, which defines A as the number of technological species that have ever existed in the observable universe's history. Their equation A equal n ast multiplied by FBT characterizes A as the product of n ast, or the number of habitable planets in a given volume of the universe, and FBT, which is the probability of a technological species emerging on one of these planets. The volume under consideration could be the universe as a whole, or just our galaxy. The universe is more than 13 billion years old, which means that even if there were 1,000 civilizations in our galaxy, if they only lived as long as we have, roughly 10,000 years, then they are all likely extinct. And others will not evolve until long after we are gone. In order for us to have a good chance of discovering another contemporary active technological civilization, they must on average outlive our own. Given the immense distances between stars, and the constant speed of light, we may never truly be able to communicate with another civilization. If they were 10,000 light years away, each exchange would take 20,000 years, and this is well inside our galaxy. Even if there are currently no other civilizations in our galaxy with which we can communicate, the new approach to Drake equation has profound scientific and philosophical significance. The fundamental query is whether or not this has ever occurred before. It is remarkably that probable we are not the only time and place where an advanced civilization has evolved. The outcome also has practical applications. As humanity confronts its crisis in sustainability and climate change, we may ponder if other civilization-building species on other planets have survived a similar bottleneck. We do not even know if a high-tech civilization can exist for more than a few centuries. Scientists can begin simulating the interactions of an energy-intensive species with their home planet, using everything they know about planets and climate, because a large number of such cases have already occurred in the cosmos. The findings suggest that our evolution is not unique, and has likely occurred many times before. As their civilizations expand, the other cases are likely to involve numerous energy-intensive civilizations, coping with their planet's feedbacks. That means we can begin investigating the issue using simulations, to determine what factors contribute to long-lasting civilizations and which do not. Thank you for watching.